Okay, so before starting, let's have a couple of poll questions, and let me see how much do you remember from our early this week's class. Okay, so you have 40 seconds now. The question says the Laplace equation is used to solve for potential in a charge-free region. Is it true or is it false? So 20 seconds finished. $30, 35, 37, 38, 39, and 40. Okay. So if you see here, what is the answer? Yes. So maximum students said true, which is correct because Laplace equation is used to solve for potential in a charge-free region because we will get del square V is equal to 0. So 0, that means we are using the special form of the Poisson's equations where we are making rho V 0. So that's why it is used in a charge-free region, and all the region between our capacitor, the two conductors, is a charge-free region. Okay, so one more question. Again, very easy question. Again, 40 seconds. So prior knowledge of E, that is the direction of E or its dependence on the space variables existing in a dielectric region between the two conductor plates, is required to simplify the Laplace equation when solving for the potential V, which is between the two conductors, that is in the dielectric region. I'm giving 50 seconds for this. So you have 40 seconds, 44, 45, 46, 47, 48, 49, and 50. Yes, so maximum students got correct, 22. Yes, because guys, if you remember, this is what we have been doing in the examples. We are first trying to look at the electric field, how the electric field will exist, and what will the electric field components will be, and those components which depends on which space variables. Based on that, our del square V, which has 3 second order differentials, okay, dou square V, dou over dou rho square, dou over dou phi square, dou over dou z square for cylindrical coordinates. We are cancelling 2 of them, and in the end we are getting only 1 as the term left to solve. And we were able to do that from our prior knowledge of the electric field that will exist between the two conductors. So all our examples are based on that. Well, guys, the thing is, please, once we finish the topic and we move on, please don't forget, try to, increase your retention. And I felt this poll is a good way of, trying to recall what we did. And by the way, I have made my poll questions very easy now, because last time, I got some comments that it is very difficult and other things, but now the poll questions are very, very easy. So most of them are true or false. Okay, so now let's go back to our course. So let me screen share.
Okay. Doctor.
Yes.
regarding the assignment,
Yeah.
uh, I want to ask you if it's possible or not to postpone the assignment until Friday midnight. To be honest with you, I couldn't
Huh?
manage the material.
Okay, let me think about it, and I will send an email. Okay.
Doctor, we found out that it is not from the material of the quiz.
Some of, because
Yeah, doctor, only two questions is not
5 to 8,
completed.
yeah, because there are 5 questions. That's why in the that's why when I saw it, I told some of them are there.
Okay, therefore it will be helpful if it's Friday midnight in order to cover the remaining. And we will have a Saturday full day to see the solution.
Okay, no problem. Okay, so let's come back. So here I want to start our class with the review. So in the last class, we looked at the Biot-Savart's law, and where we did the example of the two semi-infinite lines. We took an example of an infinite line, and we saw how the magnetic field, the magnetostatic field looks like. And then we also did for a circle, a ring, and this ring was carrying a current I. And we saw that how the electric field looks like. I think this is where we stop. So in the analysis, this is what I told you guys, that you will get the dl cross r, you will find the h, and the h will have two terms, the az term and the a rho term. Now again here, you need to be very careful. Can I take az outside the integral? Yes, because az, the unit vector az, is not a function of phi. So therefore, in a cylindrical coordinates, you can take it outside. I already told about this. But can you take a rho outside the integral, where the integral is with respect to d phi? No. This is very similar to the assignment question, which I emphasized. So here you cannot take outside. So in order to solve this, you have to convert your a rho unit vector into the Cartesian coordinates, and there you will see that it is a function of phi. And then you do the integration in the Cartesian coordinates, and then you can get the answer in the Cartesian coordinates. And later, if you want, you can convert it into cylindrical coordinates.